In this lesson, we will use synthetic division to help us characterize polynomials, and we have the remainder theorem and factor theorem. The factor theorem is x, or here's an example, x minus 1 is a factor of a function if f of 1 is 0. If we substitute a 1 and we get 0, then that means x minus 1 is the factor. And this factor corresponds with the 0, x equals 1. All right, the remainder theorem says that if you divide by some number, then the remainder is the y value of the function at that number. If we divide it by 1, whatever we get here will be the y value for 1. So let's look at some examples. So this is how questions appear in the book. Find the y value of the polynomial when x equals 4. So here it's saying x is c, and we're going to put 4 right there. We could put 4 in for x and evaluate all of that, but we can also just do this, and this is the remainder theorem. All right, so we add, multiply, add, multiply, add, multiply, add, and this tells us that f of 4 is 177. Oops, 177. Pause the video and try that one. So we need to put the 0 in because it's missing the cubic term. Add, multiply, add, multiply, add, multiply. So this tells us that f of negative 2 is 26. Oh, while we're here, why don't we just look at No, we're going to look at the next example. Pause and try that one. Add, multiply, multiply, add, multiply, add, multiply. So this tells us that f of negative 2 is 0. And this brings us to the factor theorem. If the remainder is 0, then when you get a 0 remainder, it means that the number you divided by is a factor, or it creates a factor in this form, x minus whatever number is there. So that is the factor theorem, and this part is the remainder theorem. All right, so we want to know, is this a factor? Well, if it is a factor, then when we do synthetic division with negative 2, we'll get a remainder of 0. Same thing with this. So we want to use x minus negative 2. We're going to have that. So that means that x plus 2 is a factor. And let's check, here we'll check positive 1. Add. So we didn't get a 0, and that means that x minus 1 is not a factor. So now we have to factor the rest. We're going to use this to factor that, and we need to use this part to find this times this gives us that. So we're going to take this and make a polynomial. Those are the coefficients of the polynomial, and it's going to be 1x to the third minus 4x squared. Okay, 1, negative 4, negative 1, 3, 1, negative 4, negative 1, 3, multiplied by x plus 2. So we use synthetic division to find out the quotient of the polynomial divided by x plus 2. We know that this is equal to the original polynomial and it said factor completely. Let's just stop there, and we know that this is factored like, here's one way to factor it, but it's not factored completely. Pause and try that one. The remainder is 0, so we know that x minus 2 is a factor. And we're going to get something that is not 0 here. So we can say that f of x is x minus 2 times these coefficients in the polynomial, 3x squared plus 5x minus 12. If we start with a third degree and we divide with synthetic division once, we know we'll have a second degree. And let's see if x minus 6 and or x minus 3 are factors. Go ahead and pause and try that one. And in this one, I'm going to do something a little different than before. We don't have to always start with the original coefficients. We can just start, we can work on what's left here. So now let's check 3. All right, and this tells us that x minus 3 is a factor. So now we can factor the function as x minus 6, x minus 3, and then whatever is left here. This is 4x plus 2. Let's see if x plus 4 and x minus 5 are factors. Pause and try this one on your own. And then let's go ahead and just use the new numbers we get here, and we'll test 5. And that works. So now we know that f can be factored as, x minus 5 is a factor. And we get 2x plus 1 from there, and those are the, and that's factored completely. All right, that's it for today.